And good afternoon everyone. My name is Muhammad Anwar bin Haizat. We are group 4G. We given a title ACETYLENE production plant from partial oxidation of hydrocarbon feedstock. Today we're going to discuss on process safety and loss prevention. As the PSLP, we will focus on the safety analysis, identification of the risk, and suggestion of solution to mitigate the risk itself. As you can see, many catastrophic accidents had happened and will lead to the loss of economical value of the plant. So, safety analysis consists of three methods, which is HAZOP, Hazard and Operation Study, Hazard Identification of Risk, and PHA, Preliminary Hazard Analysis. For this plant, we choose the acetylene absorber as one of our focus of study. As you can see here, the acetylene solver consists of inlet of solvent. Select solvent, we absorb the acetylene itself. A product from the reactant burner itself. Solvent, we absorb the acetylene, and the syngas, which consists of mainly hydrogen, will separate on the top. As you can see, there is a many potential risks here as we deal with the H2, acetylene, CO and CO2, which is highly flammable. So in this video, we will discuss the risk. We will point any parameter that can produce a hazard, and we will suggest a mitigation for this plant. Share and we will continue to my friend.
Assalamualaikum and hi, I am Farah Atika. Will be explaining about the hazard of the absorber column. We are having four main hazards, which is the corrosion, the fire or explosion, the overheating, and overpressurization. The first one, the corrosion, actually have two types of corrosion, which is the internal corrosion, which is the corrosion that happens internally inside the column, and the external corrosion, which is happen visibly. And the second hazard is the fire explosion. The fire explosion is due to the acetylene that has wide range of flammability and extremely flammable when in contact with the oxygen. So any leakage of acetylene in the absorber will cause the fire or the explosion. The third one is the overheating. Overheating focus on the temperature of the fluid and also the Joule-Thomson effect. The Joule-Thomson effect is actually the temperature changes of the liquid when the liquid is passing through the column. The last hazard is actually the overpressurization. The overpressurization is due to the high pressure of the liquid being passed from the CO2 scrubber to the absorber. The liquid shall be regulated by the valve, but if the valve is malfunctioning, it will cause the high pressure of the liquid be passed directly to the absorber, will cause the overpressurization of the absorber column.
My name is Nasrin Fatini binti Ahmad Fauzi. So today I'm going to explain about HAZOP study on the absorption column. So HAZOP study is hazard and operability analysis. It is one of hazard identification method so that the hazard can be eliminated or controlled. HAZOP study is the systemic examination of process engineering aspect of production facilities which the operating condition can deviate from the normal condition. So on this screen you can see the example of HAZOP study of acetylene production by partial oxidation from hydrocarbon feedstock. So on the second column of the HAZOP study is the study note where the location of the process that potential hazard can take place. On the next column is the parameter of the process such as flow rate, temperature, or pressure. And the next column is the guide word where the site of guidance about deviation at normal condition. And the next column is the possible causes of the hazard and the possible consequences that can occur if the process deviates from normal condition. And last but not least is the action required to mitigate the hazard. So I take the example from this table. We can see is stream 13, which is the DMF feed into the absorption column. So the process parameter for this study node is the level. If the level of the DMF feed in the pack column is increased, which caused by the level controller malfunctioning, can cause the flooding, which lead to the large pressure drop in the pack column. How we mitigate the hazard? We can install a level controller, or we can install a pressure gauge which can monitor the level of DMF in the pack column. So that's all from me.
Good evening everyone, I am Siti Nofatia binti Adnan from Group 4G. Today I will proceed with the recommendation to improve the safety aspect of the absorber itself. Firstly, to prevent corrosion, it is recommended to use the best material for designing the absorber, which is a high alloy stainless steel component, because it has an excellent resistance toward corrosion compared to carbon steel, galvanic steel and aluminium. Other than that, it also has better prevention towards fire. The next one, for the prevention of fire, we need to install the vent system and active fire protection. The vent system, also known as relief system, where it has normal and emergency ventilation system. The normal one, we need to install the vacuum pressure relief, and the emergency, we need to install the rupture device. And the active fire protection is installing the water spray to avoid propagation of the flame itself. And by the outlet of the vent system, we can install the fire trap, which it will have the fire control. Next one, to avoid from overheating, we need to have flammable handling, which is there's 3 parts. The first one, to install the absorber emergency plant. The second one is to have the fire hydrant system, and the third one, to install the alarm alert system for temperature. And the last one, for mitigate the overpressure hazard, we need to have the safety valve, vent system and also alarm system. The safety valve is where the valve we install at the inlet stream of the absorber. It can detect the deviation of the normal pressure, and if there is any overpressure, they will flow it to the atmosphere. For the vent system, it has the same work mechanism as mentioned earlier in the fire pipe. And the last one, for the alarm system, we need to install the alarm alert system for the pressure. If there is any overpressure happen, the alarm system will give alert to the operator.
Assalamu alaikum, my name is Abdul Karim from Group 4G, and I'll be concluding our video presentation by giving a brief description on our project, which is titled as Acetylene Production by Partial Oxidation of Hydrocarbon Feedstock. So first, we chose our node of study, which is our absorber, and we identified some hazards which were due to corrosion, fire and explosion, overheating and overpressurization. We later on made a HAZOP study, and we managed to identify all the possible causes, consequences and required actions needed to mitigate the hazards we identified in the HAZOP study. And lastly, these are the recommendations on how to improve the safety aspect of our absorber. So first, by selecting the best possible material for the construction of the absorber. Second, by installing vent system and fire protection. Third, by installing safety valve, relief systems and alarm systems which will monitor the pressure. And lastly, flammable handling. That's all from me and from our group. Thank you.